A year is a unit of time based on how long it takes the Earth to orbit the Sun. In scientific use, the tropical year, approximately 365 solar days, 5 hours, 48 minutes, 45 seconds, and the sidereal year, about 20 minutes longer, are more exact. The modern calendar year, as reckoned according to the Gregorian calendar, approximates the tropical year by using a system of leap years. The term year is also used to indicate other periods of roughly similar duration, such as the lunar year, a roughly 354-day cycle of 12 of the moon's phases, see lunar calendar, as well as periods loosely associated with the calendar or astronomical year, such as the seasonal year, the fiscal year, the academic year, etc. Due to the Earth's axial tilt, the course of a year sees the passing of the seasons, marked by changes in weather, the hours of daylight, and, consequently, vegetation and soil fertility. In temperate and subpolar regions around the planet, 4 seasons are generally recognized: spring, summer, autumn, and winter. In tropical and subtropical regions, several geographical sectors do not present defined seasons, but in the seasonal tropics, the annual wet and dry seasons are recognized and tracked. By extension, the term year can also be applied to the time taken for the orbit of any astronomical object around its primary, for example the Martian year of roughly 1.88 Earth years. The term can also be used in reference to any long period or cycle, such as the Great Year. A calendar year is an approximation of the number of days of the Earth's orbital period, as counted in a given calendar. The Gregorian calendar, or modern calendar, presents its calendar year to be either a common year of 365 days or a leap year of 366 days, as do the Julian calendars. For the Gregorian calendar, the average length of the calendar year, the mean year, across the complete leap cycle of 400 years is 365.2425 days, 97 out of 400 years are leap years. In English, the unit of time for year is commonly abbreviated as Y or year. The symbol A, for Latin, annus, year, is sometimes used in scientific literature, though its exact duration may be inconsistent. Astronomical years do not have an integer number of days or lunar months. Any calendar that follows an astronomical year must have a system of intercalation such as leap years. In the Julian calendar, the average, mean, length of a year is 365.25 days. In a non-leap year, there are 365 days, in a leap year there are 366 days. A leap year occurs every 4th year during which a leap day is intercalated into the month of February. The name leap day is applied to the added day. In astronomy, the Julian year is a unit of time defined as 365.25 days, each of exactly 86,400 seconds, SI base unit, totaling exactly 31,557,600 seconds in the Julian astronomical year. The revised Julian calendar, proposed in 1923 and used in some Eastern Orthodox churches, has 218 leap years every 900 years, for the average, mean, year length of 365.242222 days, close to the length of the mean tropical year, 365.24219 days, relative error of 9/10. In the year 2800 CE, the Gregorian and revised Julian calendars will begin to differ by 1 calendar day. The Gregorian calendar aims to ensure that the northward equinox falls on or shortly before March 21 and hence it follows the northward equinox year, or tropical year. Because 97 out of 400 years are leap years, the mean length of the Gregorian calendar year is 365.2425 days, with a relative error below 1 ppm, 8/10, relative to the current length of the mean tropical year, 365.242189 days, and even closer to the current March equinox year of 365.242374 days that it aims to match. Historically, lunisolar calendars intercalated entire leap months on an observational basis. Lunisolar calendars have mostly fallen out of use except for liturgical reasons, Hebrew calendar, various Hindu calendars. A modern adaptation of the historical Jalali calendar, known as the solar Hijri calendar, 1925, is a purely solar calendar with an irregular pattern of leap days based on observation, or astronomical computation, aiming to place New Year, Nowruz, on the day of vernal equinox, for the time zone of Tehran, as opposed to using an algorithmic system of leap years. A calendar era assigns a cardinal number to each sequential year, using a reference event in the past, called the epoch, as the beginning of the era. The Gregorian calendar era is the world's most widely used civil calendar. Its epoch is a 6th century estimate of the date of birth of Jesus of Nazareth. Two notations are used to indicate year numbering in the Gregorian calendar: the Christian Anno Domini, meaning in the year of the Lord, abbreviated AD, and Common Era, abbreviated CE, preferred by many of other faiths and none. Year numbers are based on inclusive counting, so that there is no year zero. Years before the epoch are abbreviated BC for before Christ or BCE for before the Common Era. In astronomical year numbering, positive numbers indicate years AD/CE, the number 0 designates 1 BC/BCE, 1 designates 2 BC/BCE, and so on. Other eras include that of ancient Rome, ab urbi condita, from the foundation of the city, abbreviated AUC, Anno Mundi, year of the world, used for the Hebrew calendar and abbreviated AM, and the Japanese imperial eras. The Islamic Hijri year, year of the Hijra, Anno Hijri abbreviated A, is a lunar calendar of 12 lunar months and thus is shorter than a solar year. Pragmatic divisions. Financial and scientific calculations often use a 365-day calendar to simplify daily rates. A fiscal year or financial year is a 12-month period used for calculating annual financial statements in businesses and other organizations. In many jurisdictions, regulations regarding accounting require such reports once per 12 months, but do not require that the 12 months constitute a calendar year. For example, in Canada and India the fiscal year runs from April 1st, in the United Kingdom it runs from April 1st for purposes of corporation tax and government financial statements, but from April 6th for purposes of personal taxation and payment of state benefits. In Australia it runs from July 1st, while in the United States the fiscal year of the federal government runs from October 1st. An academic year is the annual period during which a student attends an educational institution. The academic year may be divided into academic terms, such as semesters or quarters. The school year in many countries starts in August or September and ends in May, June, or July. In Israel the academic year begins around October or November, aligned with the second month of the Hebrew calendar. Some schools in the UK, Canada, and the United States divide the academic year into 3 roughly equal-length terms, called trimesters or quarters in the United States, roughly coinciding with autumn, winter, and spring. At some, a shortened summer session, sometimes considered part of the regular academic year, is attended by students on a voluntary or elective basis. Other schools break the year into 2 main semesters, a first, typically August through December, and a second semester, January through May. Each of these main semesters may be split in half by midterm exams, and each of the halves is referred to as a quarter, or term in some countries. There may also be a voluntary summer session or a short January session. Some other schools, including some in the United States, have 4 marking periods. Some schools in the United States, notably Boston Latin School, may divide the year into 5 or more marking periods. Some state in defense of this that there is perhaps a positive correlation between report frequency and academic achievement. There are typically 180 days of teaching each year in schools in the U.S., excluding weekends and breaks, while there are 190 days for pupils in state schools in Canada, New Zealand, and the United Kingdom, and 200 for pupils in Australia. In India the academic year normally starts from June 1st and ends on May 31st. Though schools start closing from mid-March, The actual academic closure is on May 31st, and in Nepal it starts from July 15th. Schools and universities in Australia typically have academic years that roughly align with the calendar year, i.e., starting in February or March and ending in October to December, as the Southern Hemisphere experiences summer from December to February. The Julian year, as used in astronomy and other sciences, is a time unit now defined as exactly 365.25 days of 86,400 SI seconds each, ephemeris days. This is one meaning of the unit year used in various scientific contexts. The Julian century of 36,525 ephemeris days and the Julian millennium of 365,250 ephemeris days are used in astronomical calculations. Fundamentally, expressing a time interval in Julian years is a way to precisely specify an amount of time, not how many real years, for long time intervals where stating the number of ephemeris days would be unwieldy and unintuitive. By convention, the Julian year is used in the computation of the distance covered by a light year. The scientific Julian year is not to be confused with a year in the Julian calendar. The scientific Julian year is a multiple of the SI second. It is today astronomical only in the sense used in astronomy, whilst true astronomical years are based on the movements of celestial bodies. Each of these 3 years can be loosely called an astronomical year. The sidereal year is the time taken for the Earth to complete one revolution of its orbit, as measured against a fixed frame of reference, such as the fixed stars, Latin sidera, singular sidus. Its average duration is 365.256363004 days, 365 d6 h9 minutes 9.76 s, at the epoch J 2000.0 equals January 1, 2000, 12 hours TT. Today the mean tropical year is defined as the period of time for the mean ecliptic longitude of the Sun to increase by 360 degrees. Since the Sun's ecliptic longitude is measured with respect to the equinox, the tropical year comprises a complete cycle of the seasons and is the basis of solar calendars such as the internationally used Gregorian calendar. The modern definition of mean tropical year differs from the actual time between passages of, example the northward equinox, by a minute or two, for several reasons explained below. Because of the Earth's axial precession, this year is about 20 minutes shorter than the sidereal year. The mean tropical year is approximately 365 days, 5 hours, 48 minutes, 45 seconds, using the modern definition, equals 365.24219 d times 86,400 s. The length of the tropical year varies a bit over thousands of years because the rate of axial precession is not constant. The anomalistic year is the time taken for the Earth to complete one revolution with respect to its apsides. The orbit of the Earth is elliptical. The extreme points, called apsides, are the perihelion, where the Earth is closest to the Sun, and the aphelion, where the Earth is farthest from the Sun. The anomalistic year is usually defined as the time between perihelion passages. Its average duration is 365.2596636 days, 365 d6 h 13 minutes 52.6 s, at the epoch J 2011.0. The draconic year, draconitic year, eclipse year, or ecliptic year is the time taken for the Sun, as seen from the Earth, to complete one revolution with respect to the same lunar node, a point where the Moon's orbit intersects the ecliptic. The year is associated with eclipses. These occur only when both the Sun and the Moon are near these nodes, so eclipses occur within about a month of every half eclipse year. Hence there are 2 eclipse seasons every eclipse year. The average duration of the eclipse year is 346.620075883 days, 346 d14 h 52 minutes 54 s, at the epoch J 2000.0. This term is sometimes erroneously used for the draconic or nodal period of lunar precession, that is the period of a complete revolution of the Moon's ascending node around the ecliptic, 18.61281592 Julian years, 6,798.331019 days, at the epoch J 2000.0. The full moon cycle is the time for the Sun, as seen from the Earth, to complete one revolution with respect to the perigee of the Moon's orbit. This period is associated with the apparent size of the full moon, and also with the varying duration of the synodic month. The lunar year comprises 12 full cycles of the phases of the moon, as seen from Earth. It has a duration of approximately 354.37 days. Muslims use this for religious purposes, including calculating the date of the Hajj and the fasting month of Ramadan, and thus also the Eids. The Jewish calendar is also mainly lunar, but with the addition of an intercalary lunar month once every 2 or 3 years, designed to keep the calendar broadly synchronous with the solar cycle. Thus, a lunar year on the Jewish, Hebrew, calendar consists of either 12 or 13 lunar months. The vague year, from annus vagus or wandering year, is an integral approximation to the year equaling 365 days, which wanders in relation to more exact years. Typically the vague year is divided into 12 schematic months of 30 days each plus 5 epigomenal days. The vague year was used in the calendars of Ethiopia, ancient Egypt, Iran, Armenia, and in Mesoamerica among the Aztecs and Maya. It is still used by many Zoroastrian communities. A heliacal year is the interval between the heliacal risings of a star. It differs from the sidereal year for stars away from the ecliptic due mainly to the precession of the equinoxes. The Sothic year is the heliacal year, the interval between heliacal risings, of the star Sirius. It is currently less than the sidereal year and its duration is very close to the Julian year of 365.25 days. The Gaussian year is the sidereal year for a planet of negligible mass, relative to the Sun, and unperturbed by other planets that is governed by the Gaussian gravitational constant. Such a planet would be slightly closer to the Sun than Earth's mean distance. The Besselian year is a tropical year that starts when the fictitious mean Sun reaches an ecliptic longitude of 280 degrees. This is currently on or close to January 1st. It is named after the 19th century German astronomer and mathematician Friedrich Bessel. The TT subscript indicates that for this formula, the Julian date should use the terrestrial time scale, or its predecessor, ephemeris time. Variation in the length of the year and the day. The exact length of an astronomical year changes over time. The positions of the equinox and solstice points with respect to the apsides of Earth's orbit change. The equinoxes and solstices move westward relative to the stars because of precession, and the apsides move in the other direction because of the long-term effects of gravitational pull by the other planets. Since the speed of the Earth varies according to its position in its orbit as measured from its perihelion, Earth's speed when in a solstice or equinox point changes over time. If such a point moves toward perihelion, the interval between two passages decreases a little from year to year. If the point moves towards aphelion, that period increases a little from year to year. So a tropical year measured from one passage of the northward, vernal, equinox to the next, differs from the one measured between passages of the southward, autumnal, equinox. The average over the full orbit does not change because of this, so the length of the average tropical year does not change because of this second-order effect. Each planet's movement is perturbed by the gravity of every other planet. This leads to short-term fluctuations in its speed, and therefore its period from year to year. Moreover, it causes long-term changes in its orbit, and therefore also long-term changes in these periods. Tidal drag between the Earth and the Moon and Sun increases the length of the day and of the month, by transferring angular momentum from the rotation of the Earth to the revolution of the Moon. Since the apparent mean solar day is the unit with which we measure the length of the year in civil life, the length of the year appears to decrease. The rotation rate of the Earth is also changed by factors such as post-glacial rebound and sea level rise. Numerical value of year variation. Mean year lengths in this section are calculated for 2000, and differences in year lengths, compared to 2000, are given for past and future years. In the tables, a day is 86,400 SI seconds long. Summary. Some of the year lengths in this table are in average solar days, which are slowly getting longer, at a rate that cannot be exactly predicted in advance, and are now around 86,400.002 SI seconds. An average Gregorian year may be said to be 365.2425 days, 52.1775 weeks, and if an hour is defined as 1/24th of a day, 8,765.82 hours, 525,949.2 minutes, or 3155695.2 seconds. Note however that in absolute time the average Gregorian year is not adequately defined unless the period of the averaging, start and end dates, is stated, because each period of 400 years is longer, by more than 1000 seconds, than the preceding one as the rotation of the Earth slows. In this calendar, a common year is 365 days, 8,760 hours, 525,600 minutes, or 31536,000 seconds, and a leap year is 366 days, 8,784 hours, 527,040 minutes, or 3162240 seconds. The 400-year civil cycle of the Gregorian calendar has 146,097 days and hence exactly 20,871 weeks. The great year, or equinoctial cycle, corresponds to a complete revolution of the equinoxes around the ecliptic. Its length is about 25,700 years. The galactic year is the time it takes Earth's solar system to revolve once around the galactic center. It comprises roughly 230 million Earth years. In 2011, a task group of the IUPAC and the International Union of Geological Sciences, IUGS, jointly recommended defining the annus for geological purposes as 1A equals 3155692.5.445 seconds, approximately 365.24219265 ephemeris days. They chose a value close to the length of tropical year for the epoch 2000.0, which is roughly the length of the tropical year 2000. The length of the tropical year is slowly decreasing. However, the definition is as a multiple of the second, the SI base unit of time, and independent of astronomical definitions, since definitions of the annus that are based on an intermediate relationship via the day, such as the Julian and Gregorian year, bear an inherent, pre-programmed obsolescence. Because of the variability of Earth's orbital movement, it differs from the Julian year of 365.25 days, 3.1557600 times 107 s, by about 21 parts per million. As of April 2025, the IUPAC Green Book, 4th edition, provides a definition of the year as A equals 3155692.5.9747 seconds. A seasonal year is the time between successive recurrences of a seasonal event such as the flooding of a river, the migration of a species of bird, the flowering of a species of plant, the first frost, or the first scheduled game of a certain sport. All of these events can have wide variations of more than a month from year to year. A common symbol for the year as a unit of time is A, taken from the Latin word annus. For example, the U.S. National Institute of Standards and Technology, NIST, Guide for the Use of the International System of Units, SI, supports the symbol A as the unit of time for a year. In English, the abbreviations Y or year are more commonly used in non-scientific literature. In some earth sciences branches, geology and paleontology, KYR, mere, BYR, thousands, millions, and billions of years, respectively, and similar abbreviations are used to denote intervals of time remote from the present. In astronomy, the abbreviations KYR, mere, and gyra are in common use for kilo years, mega years, and giga years. Since 1989, the International Astronomical Union, IAU, recognizes the symbol A rather than year for a year, notes the different kinds of year, and recommends adopting the Julian year of 365.25 days, unless otherwise specified. IAU Style Manual. Since 1987, the International Union of Pure and Applied Physics, IUPAP, notes A as the general symbol for the time unit year, IUPAP Red Book. Since 1993, the International Union of Pure and Applied Chemistry, IUPAC, Green Book also uses the same symbol A, notes the difference between Gregorian year and Julian year, and adopts the former, A equals 365.2425 days, also noted in the IUPAC Gold Book. In 2011, a task group of IUPAC and IUGS recommended the use of A as the symbol for the annus, along with multiples such as Ma, for both time intervals and absolute ages. This proved controversial as it conflicts with an earlier convention among geoscientists to use A specifically for absolute age before the present, e.g. 1 Ma for 1 million years ago, and Y or year, and Mi, mere etc., for a time interval or period of time. For the following, there are alternative forms that elide the consecutive vowels, such as kilonis, meganis, etc. The exponents and exponential notations are typically used for calculating and in displaying calculations, and for conserving space, as in tables of data. In geology and paleontology, a distinction sometimes is made between abbreviation year for years and YA for years ago, combined with prefixes for thousand, million, or billion. In archaeology, dealing with more recent periods, normally expressed dates, e.g. 10,000 BC, may be used as a more traditional form than before present, BP. Use of Maya and Bia is deprecated in modern geophysics, the recommended usage being Ma and Ga for dates before present, but My for the durations of epochs. This ad hoc distinction between absolute time and time intervals is somewhat controversial amongst members of the Geological Society of America. Thank you for watching this video.